Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the quotient rule. This is in the differentiation playlist, and this is part 14. Make sure to go over the other parts prior to this part. And remember to subscribe so that you don't miss out on any of our future uploads. Once again, make sure that you check out all the other playlists that we have covered. And this is the differentiation playlist. Note, the product rule can be used in place of the quotient rule. And as you would recall, this is something that we looked at in video part 13, where we looked at the product rule and how to differentiate using the product rule. Now suppose that we have y of x is equal to u of x over v of x. This is known as the quotient, as you would know from the polynomial division. We also have a playlist on that. Make sure to check it out. It has a lot of insight. So y is a quotient of u and v. Then dy dx is equal to d dx of u over v. Now with that, we are saying that dy dx is given by v times the first derivative of u minus u times the first derivative of v all over v squared. And take note, from the product rule, we used a positive, but in the quotient rule, we are using a negative, and we are dividing not just by v, but the v squared. So take note of that. And this is known as the quotient rule. And in simple terms, y prime of x is equal to v times u prime minus u times v prime all over v squared. With that, let us take a look at the first example. Differentiate y with respect to x, where our y is equal to square root of x all over 5x minus 1. The solution. So now we are going to let the numerator be the u, that is to say u is equal to root x, and the denominator, which is the v, is 5x minus 1. Then the first derivative of u is given to be half times x to the power minus half, and the v prime is 5. Therefore, the dy dx becomes v du dx, according to the formula, minus u dv dx over v squared, and substituting for the du and the du dx and the dv dx and the v's and the u's, we are going to get that bit over here. And of course, we can simplify it further so that we have something of that particular nature. So now when we get to this stage over here, we see that we can actually simplify this one to be that, where we have 5x minus 1 minus 10x all over 2x to the power half times 5x minus 1 squared. Simplifying further, we are going to get our dy dx becoming minus 5x minus 1 all over 2 times the square root of x times 5x minus 1 squared. And that becomes our answer. Now, let's take a look at example 2. Find the equation of the normal to the curve where y is equal to x squared plus 1, this is the numerator, divided by the square root of x plus 2, which is the denominator, at the point minus 1, 2. And of course, the solution. We are going to let the numerator be u, that is to say u is equal to x squared plus 1, and the denominator be v. V is equal to x plus 2 raised to the power half. This is from the laws of indices once again, and I encourage you to check the video out on indices that we have uploaded. Then this would imply that the first derivative, recall from the quick and easy substitution method that we covered in video part 12, this is how we get the answers. So u prime becomes 2x, which is the first derivative of x squared plus 1. And the v prime becomes half times 1 times x plus 2 raised to the power minus a half. Now, we have the formula on the left-hand side. So wherever we have u, v, u prime, and v prime, we simply substitute into that formula. So it is important to recall that formula, to always have that formula. So now with that, we have that. And of course, we can move on to simplify what we have so that the denominator, since we have to the power half, and also having the squared outside the brackets or the pair of parentheses, we are going to end up having x plus 2 as the denominator. And of course, keeping the numerator the way it is for now, we can actually now move on to separate the fraction into 2 bits and pieces. And of course, making use of the laws of indices, we see that x plus 2 raised to the power half divided by x plus 2. It means that the powers would subtract. Half minus 1 would give us x plus 2 raised to the power minus half. The same goes for the other bit, so that we have the x plus 2 raised to the power minus 3 over 2. Now that we have the y prime of x, we don't need to simplify further because all we are interested in is getting the gradient of the tangent at the point minus 1, 2. So the gradient of the tangent at the point minus 1, 2, we simply substitute. Where we have x, we substitute it with the x coordinate, which is a minus 1. So in that particular y prime formula that we have, we are going to substitute the x with a minus 1. That is to say that we have this chunk on the right-hand side over here. And of course, this is easy to simplify because we see that in most parentheses, we are going to get 1s. And in some cases, we are going to get 2s. So that simplifying further, we are going to get a minus 2 minus half times 2. And of course, this would break down to be the y prime of minus 1 is equal to minus 3. Therefore, the gradient of the normal at the point minus 1, 2 becomes 1 divided by minus 1 over 3. As you would know and recall, the relationship that we have between the gradient of the tangent and the gradient of the normal is given by that. Right, so that will imply that the gradient of the normal is equal to positive 1 over 3. Now that we have the gradient of the normal, and we have also the point at which the normal passes through, which is the point minus 1, 2, we can go on to find the equation of the normal through the point minus 1, 2. Right, so now, since we know that the gradient is changing y over change in x, so we are going to have that the change in y, making use of the y coordinate and also the x coordinate, we equate that to the gradient. So with that, we make y the subject of the formula. So firstly, we move all the x terms, that is to say the denominator, on the left-hand side to the right-hand side, so that we have y minus 2 is equal to a third of x plus a third. Then moving the 2 to the other side, we end up having y is equal to a third of x plus 2 and a third. Now that gives us the equation of the normal through the point minus 1, 2. So if you have made it thus far, I say congratulations to you. And I leave you with the following task. So make sure to post in your answers and even questions that you may have on this series. Thank you so much for watching Numbers Simplified. Make sure to subscribe so that you don't miss out on any of our future uploads. And remember, God loves you.